హలో
సార్
ఇది పీపీటీ నాది మెయిల్లో ఉంది. ఈ మెయిల్లో నుంచి ఇప్పుడు డైరెక్ట్గా ప్రెజెంటేషన్ చేయలేమా?
లేదు సార్, మీరు ఒకసారి డౌన్లోడ్ చేయండి పీపీటీని మెయిల్ నుంచి. సో డౌన్లోడ్ చేసి ఓపెన్ చేస్తే మాకు కనిపిస్తుంది. సార్ మెయిల్ ఓపెన్ చేసి డౌన్లోడ్ చేయండి.
మ్యామ్ చెప్పండి మ్యామ్. ఓకే పీడిఎఫ్ నుంచి చెప్పొచ్చా?
Sir, if you have any problem, send us the PPT, sir. So we'll present them.
No, it's okay. But now you are able to see? See
No,
now.
we are not able to see. You just do one thing. Whatever the open share tray, no, sir, you just stop sharing and then again you start sharing the screen with the PPT.
Okay, just wait. Stop sharing, okay?
Yes. And then open the PPT in your screen, then start sharing.
I'll try to wait. Yes, I have opened. Yes, now?
Sir, did you share with the option then?
No, I'm sharing through PDF.
Sir, PDF, there is a problem with the zoom option. No, sir, better to present in PPT only and then share with your this arrow.
Actually, in my laptop, this PPT is Microsoft PPT. It's not there. Like like Word, Excel, PPT will be there now.
Okay.
It's not installed, so it's not. So that's the problem. I'm not
Sir,
able.
do one thing, sir. If you have a mail with you, just forward us. We just scroll on the PPT and just you continue then.
Okay, that will be better. Okay, I'll
That
try.
that is better, sir.
Okay, sure. I'll mail you then. Okay. I have mailed you.
Yes, sir.
Just check. Okay.
మేడం మీరు షేర్ చేస్తారా?
ఎస్ సార్ చేస్తాను, ఒక్క నిమిషం ఓపెన్ చేస్తాను.
రైట్ మ్యామ్, ఓకే.
Just download this and into PPT format.
Sir, you are sharing through Google Drive, sir.
Yeah, Google Drive. Is it any problem? You can directly save as PPT. Save as Microsoft PPT. Save that file as Microsoft PPT.
మేడం ఒకవేళ మీకు ఏం ప్రాబ్లం ఉంటే నాకు పంపించి డౌన్లోడ్ చేసి షేర్ చేస్తాను.
Sir,
లక్ష్మ
sir,
నాకు పంపించండి, నేను షేర్ చేస్తాను అంట.
yes, open అయింది.
రైట్ మ్యామ్, రైట్.
అయిపోయింది, జస్ట్ ఓపెనింగ్. Yes, sir. Shall we start then?
Yes. But I'm not able to see the slides.
Yes, sir. Just I'm
Yeah.
presenting my screen. Are you able to see my screen then?
No, I'm just able to see you, but I'm not able to see the screen. Yes. Yes, now I can able to see your screen.
Sir, Mallikarjun, sir.
చెప్పండి.
Shall we start or wait for some time, sir?
మ్యామ్
Shall we start our webinar or will wait for some time?
స్టార్ట్ చేసేది మ్యామ్. ఇంకా ఆల్రెడీ 5:20 అయిపోయింది మ్యామ్.
Yes, sir.
యా.
Good evening, one and all. Today's webinar session is on civil engineering key skills, applied hydrology and GIS. And our guest of honor, I'm very glad to introduce our guest of honor, Mr. M. Vamshi Ras, sir. So he's a he is assistant engineer, officer of chief engineer hydrology investigation and irrigation and CAD department, and his present position is assistant executive engineer in that irrigation and CAD department of Telangana state. So his areas of interest are rainfall runoff modeling and then catchment hydrology and flood forecasting. So he is expertise in remote sensing and GIS skills as well as in applied hydrology. So I'm glad to invite him to present his lectures. Today's guest lecture.
Okay.
Just I over to Mr. Vamsi Ras, sir.
Okay. Good evening. Good evening, dear participants in this webinar. Yeah. Myself, Vamshi Raj. I think I already introduced as Lakshmi Madam introduced. Yeah, I'm not able to see the screen fully. I'm not able to see the screen fully. Means from my end, is there any problem? Can I maximize this? Yeah, okay. Wait, just the problems. Okay. Yeah, as yeah, myself, Vamshiraj, yeah, I'm working in irrigation CAD department, Government of Telangana. Yeah, my uh, yeah, the topic, as I said, I have chosen this topic, this title, because I will try to touch upon all these topics: civil engineering, what is civil engineering, and key skills. What are the different skills which are needed? Like if you come out of the like engineering college, like fresh engineering, if you are out of engineering college, what are the skills that are needed? Next, out of those skills, I'll be more inclined, I'll be more giving you detail or describing whatever these skills, applied hydrology and GIS. So these are the things. Next slide, man. Yeah, civil engineering basically deals with the design, construction. Just no need to, of course, you all know this thing, but still I wanted to give a slight intro about civil engineering, what is mainly it deals. I have taken this from Wikipedia. Civil engineering deals with the design, construction, and maintenance of physical and naturally built environment, including public works such as roads, bridges, canals, dams, and pipelines. These are the different components. Like normally, we tend to feel like civil engineering means it's all about buildings, only structures. Now there are different components. Are there different kind of structures? Even structures also, we tend to deal with so many different kinds of structures. Not only the structures on the land, on the earth, or structures on the rivers. So there are different like transportation on the structures, like we have metro, like we will be having such piers. So different kind of structures are there. So varied, we will be dealing with different kind of structures. So for each kind of structures, we need to solve in a different way, different pattern. Madam, can you play that link? I just wanted to give you a slight intro about the civil engineering, a brief intro. Can you link that? Can you click on that? Just with the help of a small video. No, back. No, just on that slide only, you have a hyperlink. If you can click it
Yes,
on
sir.
that slide only. Yeah, it's playing. Just it's a brief intro. Actually, brief. Just I wanted to give what are the things which are being solved by civil engineer in our daily. What are the problems which are dealt by civil engineering people? So these are the small intro. Just wanted to give. That's why I have.
So, how does civil engineering shape our work?
How do we protect people from water-related hazards like flooding?
Looking at this simulation, what are the challenges for building safer schools in Nepal? This is something that you can do with different level of technology.
How do we design cities to improve our standards of living?
Getting everybody on board and involved because so it's a major refurb. We're taking the roof off. What do you think are the constraints with a project like this? Improve the acoustics and visuals.
How can we develop our construction processes to lower our carbon footprint?
So we got examples of instability in these slopes where they could collapse and undermine structures above. What do you think this means for communities who have to build on such high-risk slopes?
What sort of methods of stability could they use? Are there any ways that bridges can be protected from the flood?
What techniques are used in the design of masonry structures to ensure that they're earthquake resilient?
Is it possible to retrofit existing structures to make them more resistant?
Yeah. So This is a University of Bristol. This is a small video which is explaining the problems which we deal. You can go back to the slide, madam. Yes. These are the means not only civil engineering means it has so many. Yeah, you can close it up. I think I have. Yes. Civil engineering not only deals with the buildings, there are many things which we try to solve. It might be like environment in an environmental way, or it might be like structures on the, like we'll be trying to solve floods, we'll be trying to assess the floods, we'll trying to see the water ability. So these are all the things which will deal with. Actually normally we come, if we come out of like college, engineering college, we try to think civil engineering in a single-minded fashion. Normally structures, only structures, like all those structures, it's good. It's like everyone thinks that structures we can do good work. Everyone loves structures, but there are many things, so many parameters, so many aspects are there in civil engineering which you can go, which you can, so many fields are there which you can venture into. Okay, just wanted to give that in that brief video. I think there's a problem with the audio. I think maybe sorry for the disturbance. So these are the goals of the presentation. I wanted to give overview of a total irrigation department in this presentation. Next, other objective is I will try to explain the significance of hydrology. What is the hydrology? What is the importance of hydrology in a civil engineering domain? Next, what are different problems dealt by a typical hydrologist? Next, I will try to see what are the different basic skills, so which are needed for in solving the problems of a hydrologist. So it takes how the GIS softwares like QGIS or ArcGIS, or there are many softwares are there which are used for solving the problems in the hydrology. Next, HECRAS, there are, so if time permits, I'll try to see this HECRAS also. And there is a recent advancements are there. Google Earth Engine. This is a wonderful software. If you have like time, you can go through. I'll try to give a brief exposure to this. This anyone Google Earth Engine, like if you have a Gmail, you can create an account, and based upon that you yourself can work out on. You don't need any other, you don't need to have any other data. It's freely used, like it's not a software, it's like an open domain, like Gmail is there. Like in that sense, Google Earth Engine, you will be using Google Earth data. Google Earth data, what are the data that is being captured by satellites, you can directly use it on the drive itself. Google Drive, like you have a Google Drive, you have a Gmail, on that only you don't need any storage space also. Normally when we use softwares, we will be running out of memory, but you don't need to have memory on your system also. Just it will save the whatever work in your drive only, Google Drive only. So it's a wonderful software. If you have time, you just go through it. I'll try to give it a brief overview on that. Next slide. Yes, these are the contents. Like I'll be giving, as I said, I'll be giving an overview of irrigation department and challenges. What are the challenges in designing a hydraulic structure? Like typical building structure is there and hydraulic structure is there. What is the basic difference in between designing the hydraulic structure? What are the challenges which we have, extra challenges what we will face when we design a hydraulic structure? Next, problems addressed by hydrologists. Next, what are the key parameters which we look into whenever we try to solve like floods, water availability, or many kind of problems are there. So what are the key parameters which influences the problems? I think I'm going in a one way. If participants, I think all I can see from the screen, there are 21 participants are there in this webinar. You can interrupt me at any point of my time, because I don't want this webinar to be like one way. I like to be, normally when I take sessions or like this, I'll try to have interaction with the participants. So the students are like this. In any way, in any place, if you are want to raise any doubt, you do want to ask anything, you are free to ask. Okay. So just continuing. So these are various tools I will be dealing with. Next slide. I will be trying to see, and also I will be trying to solve with the help of case study. I will trying to see the recent floods in a Warangal district. I'll try to explain this, how the what are the causes of floods, and what are the things which can be done. Now, these are the problems which are dealt by hydrologists, like studying extremes. Extremes means it not only floods. Whenever we talk of like water, rainfall, high rainfall, we'll talk only about floods. But there are problems like droughts also. Like whenever there is a lack of water, whenever there is a lack of water, then we'll suffer. We'll suffer a lot. It will lead to so many problems. So droughts also it's need to be studied. Next, what are the other things which will do, like fixing of MFL? MFL means maximum flood level of structures. Like whenever we build a structure, bridges or culverts, these things. So structurally, okay, we try to see what are the types of loads which are going to come on the structure. Like normally we'll study. There are shear force, bending moment, all these things which we'll try to study. But we need to see the how much level it will rise whenever there is a flooding scenario is there, how much level. So that level also we try to fix it before only, before the construction of a structure. This is also one of the important thing which we'll try to see. Next, review of the design flood, like any existing structure is there. If there is any problem, we try to review this. Next, flood forecasting, flood routing. So these things, in case of floods, like we try to forecast before only. Like after occurring of flood, it's not the thing. Like we will try to forecast before only. If there is a rainfall that is occurring about 1,000 kilometers on the upstream side, we try to see what is the effect in our location. So based upon that rainfall. So that is nothing but forecasting. So we'll try to issue warnings. So this is going, there is chance of flooding is there. So we'll try to evacuate people who are there in the down places, the people who are living in a low lying areas. We try to evacuate. So these are flood forecasting, these things. Flood routing. So there is a connect, like for example, when you see projects are there, different projects are there, like Jurala, Narjansar project. These are different projects are there, major projects are there. We try to route the floods. Whenever huge flood is coming from the upstream side, we try to route it so that the effect of the flood will be lesser. So this is also one of the problem. Next, water availability. Whenever we plan a new project, we try to see if there is in a location, we'll try to see at that location, is there any water? First of all, we need to see is there water, because building a structure, it's okay. But ultimately an irrigation structure or a hydraulic structure has to store water. So has to store water. Then afterwards, we need to supply the water whenever there is a lack of water. So that's an important purpose. So first of all, we need to study, is there water that is available or there at that point. So based upon that only, we'll try to see the water availability studies. Next, sedimentation study. Sedimentation means, like in the case of like floods, all these things, there is a huge amount of sediment also travels along the flow of the water. So we need to see the how much amount of sedimentation that is coming along the rivers. So that is also one part of the study. Next, this is I'll try to see give an overview of our department. You can click this website. I'll just if anyone of you people who are interested to join the department, I'll try to give an introduction. Now this, click this project here, projects. Yeah, basically we have divided all these projects which are handled by the department into three types, like major, medium and minor. So this classification is based upon the ICAT. ICAT means the project which is going to serve that area, the total area on the downstream of the project. ICAT means, I think you people will be knowing, the area which is going to supplied for the irrigation purpose, how much area it is going to be irrigated with the help of that project, with that help of that scheme. If there is any scheme, is there any small project or big project, how much area that's going to be irrigated with the help of that water through canals or whatever these things. So we need to, so that is nothing but ICAT. So based upon that ICAT, we have divided this in our state, we have divided it major, medium and minor. Major means if it is above 10,000 hectares, that is called as major irrigation project. If it is below 2,000 hectares, it is called as minor irrigation project. If it is in between 2,000 and 10,000, that is called as medium irrigation project. This is the basic classification, basic what we call classified based upon that how we have classified the types of projects. Minor project means, like Mission Kakatiya, which is being launched or by our government. I think this is one of the biggest achievement as the government put it, it's one of around 50,000 tanks being irrigated. 50,000 tanks been planned in this minor irrigation schemes. So major projects, I think Nagarjuna Sagar project. These are all the major projects. So in between this is called a medium irrigation project. Like if you are next, madam, just go to this organization chart. Just click that organization chart. I'll try to give you an overview of our department. Yes. See, first of all, how the structure is there. Like we'll be having a principal secretary who will reporting to the government. Next, we have these ENCs. We have 6 ENCs. ENCs who will be controlling the whole unit. So it's like ENC admin, ENC irrigation. So around 5 ENCs are there. Next, around 12 chief engineers are there. So chief engineers which are handle different districts or different these things. Now here, this is my office. You can see chief engineer hydrology investigation. We try to understand, anyway, I have explained that. We try to see water availability, flooding scenario. Okay. Okay, madam, come back now. Just close this website. Now I will go to the PPT. So this is an overview. Just wanted to give the department. Next slide. Now, what are the challenges? Okay, it's okay. The problems are there, like flooding, water availability, these things. But what are the challenges? So how the challenges? What are the challenges which we face normally? Difficulty in getting the data. Data means data will be different data. Like for example, if you are planning for a flood, like water availability at a location, we need to have historical data about 30 years or 40 years of continuous data. So there is a lack of problem of getting a continuous data. So that's one of the problem. Next, uncertainty. This is one of the huge problem. You don't know what kind of parameter gonna influence that flows at that point. So that is also one of the important parameter which is gonna affect. So we try to understand the flow parameter which are responsible, which is going to affect that flows at that particular point. We try to study as much as possible so that, but still there will be scope. Anyone who is talking about hydrology, anyone who is talking about a hydrologic structure, definitely he has to think of this uncertainty also. You need to see what are the flow parameters. Even though you may study how much, but still there will be some kind of uncertainty will always be there. Okay, next slide. These are the key parameters which basically influences the water movement on the earth surface. In the earth surface, how the water moves. So these are the key parameters which actually influences the known parameters till now, at least you can say. Like as I said in between, in before slide, there is uncertainty is involved. Still, we don't know. Still now, whatever research it is being done till now, these are the parameters which is being considered, which is going to affect the flooding or water availability. So these are things in a typical hydrological designs. So these are things which are being taken into consideration every time when we study. So first of all, first parameter is rainfall. Definitely precipitation, whatever the rainfall or snowfall which is going to occurring in that area. So that's going to influence the water availability, water movement. Next, catchment area. Catchment area is nothing but the area which is actually influences the flow at that outlet point. I think you're able to understand if the area which is going to contribute the flow on the upland area, if there's upland area is there. So what is the area that is going to contribute the flow at that point, So that is the area that is called as catchment area. Now, the third one is type of land use and land cover. For example, there is upstream area is there. So if it is an urban area is there, so definitely the way of water movement will be different. There will be like infiltration will be less if it is a urban area is there. If concrete surfaces are there, if then there will be lesser penetration will be there, lesser infiltration will be there. So more runoff will be there. Runoff means the flow on the surface of the earth. So the flow on the surface of the earth will be more. So if it is not, if it is a forest is there, like for example, irrigation, like a field is there, then there will be infiltration. So there is lesser runoff will be there. So this also is going to affect the water movement. Next, type of soil. Soil types also will play an important role. Like if clay is there, clay means normally it doesn't permit the flow of the water. Like it doesn't. So definitely the more runoff will be there. And sand will be having higher permeability. You might be, I think, studying in geology. Sand will be having the higher permeability. So that's why there will be more movement of infiltration, more chance of infiltration into the soil. So that's why there will be lesser runoff. Next, slope terrain. If it is a highly sloped land, there will be water. Definitely, it moves very fast. So if it is not, if it's a flat terrain, water moves slowly. So you can imagine, like for example, if it is slopey terrain is there, if a project you have planned on the downstream side, so water will move very fast, very quickly. So there is a more chance of flooding. So those kind of projects, it needs to be taken into consideration for flooding scenarios. Like in our state, there is a project called Kadam. Kadam is a small project actually, but there is a more, there always will be flooding. In every year, Kadam floods. Even if with small amount of rainfall also, it leads to flooding scenario because of this slope terrain. So these are the different parameters how it affects antecedent moisture condition. Antecedent moisture condition means, like for example, rainfall is occurring today. Today we have certain amount of rainfall. So how much runoff is being generated from that rainfall? So we'll be studying. That is the normal thing we'll study. But we need to see the rainfall on the previous days also, like previous 5 days, previous 4 days, 3 days, how the rainfall was there. If it is previously also continuously rainfall was there, definitely the soil gonna get saturated. Okay, so because previous rainfall, previous soil condition, how it is there. So that also in fact plays an important role. So that is nothing but antecedent moisture condition. Next, anthropogenic activity. Anthropogenic activity is nothing but a small, like whatever the human induced, what you call disturbance or induced factor in this hydrologic cycle. For how human being is exploiting the water. Like for example, if we are constructing a dam, if you are constructing a dam at a certain location, so if it tends to hold the water. Definitely, dam main purpose is that holding of the water. If dam breaks, okay, then it leads to flooding on the downstream side. So this is also one of the reason of the floods. So anthropogenic activity, I'm just trying to explain. That flooding is because of man-made disaster, man-made flooding. It's not a natural flooding. So that is also one of the parameters. So you need to study all these parameters. You need to look into, then we can give a detailed design these things. Okay, next slide. No catchment area, as I explained, I will try to give it how this picture is there. See, the area that is contributing to the flow at the outlet point. This is what I was trying to explain. So, for example, you have certain location. This is the location. So at this location, you want to study whatever it might be, like flooding, how much flood are going to occur, or how much water that's going to come, whatever. There are two things, flooding one thing and water ability. So if you are trying to study, for example, water ability, how much water that is, for example, if you are planning a project over here, a new project you are planning. So definitely you need to study how much water that's being, it's there, how much water that's going to be there at that location. Without water, constructing a dam over there, it's useless, because the construction of dam involves huge amount of public money. So thousands of crores money being spent. So that's why we need to study, first of all, is there any water is there? Okay, so that's how we'll go about it. If, for example, if you plan a project at this location, let's suppose this is the location which you are planning a project. So we'll see this total area on the upstream side. So this is nothing but the catchment area. You are able to see this is the total catchment area. You can able to see. So from outside of this area, also a catchment, but this is a different catchment. Like it will be draining to a different draining. You're saying you're able to understand. Like for example, outside also there will be streams will be there. It will also there will be streams, but they will have it their own outlet point. So they'll be going to if flow is occurring, the flow will going to that its own outlet point. Okay, so here, but any drop which is fallen like due to rainfall, any drop, everything definitely it has to travel to this outlet point. Okay, throughout this area. This is the watershed divide. So throughout this area. So if anywhere rainfall occurs on this area, the water has to come to this area. Okay, that is nothing but catchment area. That is the easy way of saying the things. Next, area that is contributing to the flow at the outlet point. So next is, so how, for example, if you planned a new project, so new project means we need to assess the water ability in this area. So water that is available due to rainfall. Rainfall is the reason, primary reason for runoff, of course. So we need to see the whatever the rain gauge stations are there in this area. Okay, for example, what are the mandals are there? So 3-4 mandals are there. What are the mandals are there? We try to see, and mandal rainfall we try to see, mandal rainfall patterns we'll try to see, and based upon that we'll do different studies. So for and then we'll come out with the runoff at this outlet point. So in that way we can do rainfall runoff, how much rainfall, for that rainfall how much runoff gonna occur at this point. In that way we'll see. So that is the one way of doing. And if we are lucky, for example, here if there is a GD station is there. GD station means it's a gauge discharge location. Okay, so gauge discharge location means, you just imagine this is also a river. Okay, this is a river only. Okay, just river cross section. Just see cross section. Cross section means it has a left bank, it has a right bank. Okay, so this is in cross section. So what is the flow parameter, means flow measurement, like what you call, what is the flow is nothing but discharge. Okay, what is the formula for discharge? You know, you might be knowing discharge formula is Q equal to area into velocity. Okay, so area is nothing but this cross sectional area over here. Okay, velocity is nothing but we'll be measuring the velocity over at this point. So when you multiply this area, cross section area, into velocity, we'll get the flow at this outlet point. So if you have a already observing station, that is nothing but gauge station installed by CWC actually Central Water Commission in our India. That is the apex organization which actually installs GD site at different locations. I'll give you another map. I'll show where the locations are there. So there we'll be having different flows. So there you can measure the flows at that point. So different points. So you can see. So in that way you can measure the flows at that outlet point. So like for example, you can see this is a Godavari river basin map. This is a total river basin map. Okay, so it starts, Godavari river starts from around Maharashtra, here what do you call, this is I think this is Ahmedabad, some location is there. So from here it will start and it will flow all along through Maharashtra. Okay, next Karnataka, it will cross, next Telangana. Here of course we haven't bifurcated here, the state is not bifurcated here, but here it might be boundary, somewhere here the boundary, Perur here it's there. So here like Hyderabad, you can see here, this is a Hyderabad. Okay, we are located here, you can say, so somewhere here. So but it is outside of the Godavari river. So Hyderabad is not part of a Godavari river. Okay, Godavari river basin. Hyderabad is part of a Krishna river basin, which will be there in the downside here. Krishna will flow from here in this somewhere. Okay, so here you can see there are different projects are there, like how it is traveling. This is somewhat like the path is taking place. Finally it reaches the Bay of Bengal. Here if you see here, Orissa also is there in between. Orissa, Chhattisgarh, okay, Madhya Pradesh bifurcated state. So these are all the streams which flows through that, and it will join. Finally, it will go. So this is nothing but one of the total river basin map, total Godavari river basin. In this you can see GD site, GD something names are mentioned now. So these are nothing but GD sites of CWC. So if you are lucky, for example, if you are planning a project, new project over that, then we have already observed data over there. So we try to see that data from 30 years past data. We need to see at least 30 years, 30-40 years of data. So for every year, we'll try to see how much water that is available. So in that, based upon that, we can go for the new project. like if it is a no, if we don't have sufficient amount of water, then we will say that simply that there is no need of any project because there is a lesser amount of water that is available. We can say that in that way. Okay, next slide. Okay, next slide. This is not needed. I think you need to play video here. Next slide. Next slide. Next slide. Next slide. Okay, you can able to open the link. Okay. Yeah, this is one of the floods, recently occurred flood. It's in Mulgu district. I think you might have seen in newspapers that total highway itself got submerged. I think you might have heard in the news in August. I think 15th August around that you have seen heavy rains. Continuous heavy rains were there around 4-5 days of continuous 1 week. I think around 1 week. So this has experienced huge amount of rainfall. Here Mulugu has experienced huge amount of rainfall, highest amount of rainfall in fact. So this has led to so much of flooding actually. See all through this is in highway. You can see total water is there. Total water completely. It's not in a river. It's not a big lake or some kind of like a reservoir. It's not like that. It's a normal area, but it is flooded. So it's been shown. You see the extent of flooding, how much it is flooding is taking place. So these are the problems which try to see our daily life, like normally try to see. Okay, just wanted to give that glimpse of that. Okay, you can close that, madam. I think in between you can come also, you can talk. If there is anything you can ask. Yes, go back to previous slide. Yes, okay. Continue now. Continue. Next slide. Yes. Now let's come to these are the problems which you try to solve. Now how here GIS plays an important role here. How GIS will take the help of the different softwares are there, ArcGIS or QGIS. How we'll take the help of the GIS, how it is useful in solving these problems. So that's I'll try to explain. So before that, you need to know a little bit basics, a little bit what are the different data that is being used. So these why GIS is useful is means because we don't have data. Like, we will not be having the data, continuous data. We'll suffer, as I already said. We'll be having problems with the data. So GIS helps in that data acquisition through satellites. So in all over Earth's surface, there are many hundreds and thousands of satellites orbiting around the Earth's surface, capturing every other detail of the Earth's surface. So they'll try to capture that detail and they try to send that satellite images from back to a Earth surface. Somewhere some agencies will be there, some government agencies are there. Nowadays, private companies also started taking that data and try to analyze. So private people also coming. If anyone of you are interested, then you can start a startup also. It's one of the bright like upcoming field GIS. You can also start you can use these satellites, freely available satellites are there, or you can purchase, you try to analyze. So these things are being transferred back to Earth surface. So when they capture through that photos, they'll satellite take pictures from the distance and they'll try to send these photos from their images, satellite images. We try to analyze the things. Then there is a pre-processing will takes place. We try to see what that image is showing, what the typical image is showing. I'll try to give an example. I'll show with how this typical satellite image looks like. So what is the image will show? So what are different features are there on that image? Like features means nothing like on the Earth surface there are different kind of features will be there, like water body or an Earth surface is there. Means like soil is there or a city is there. Okay, so any kind of thing, a feature like a road is there. So a reservoir is there, a water body is there. So an agriculture field is there. So these are all the different kind of information we can get from that satellite image. So based upon that we can analyze the things. There are many things we can do with that. So those things are useful. So here types of geospatial data. For example, there are different types are there. Two main things which are data, which is called as raster data and vector data. Raster data is nothing but the data, the raw data, which is being supplied from the satellites. Means after being supplied, we'll try to pre-process. Of course, this is one of the raw data which is being collected from the satellite. This is nothing but raster data. So this is the called as raster image. Like if you see in this picture, this is a raw image. Okay. So this image will have a matrix of cells or pixels organized into rows and columns where each cell represents certain information. Okay. So here if you can see, this is a raw image. Okay. So this raw image, in this it is divided into certain rows and columns. In this, each rows and columns, like you have these boxes, so each box will use certain kind of information, whatever information which is needed for our analysis purpose. So based upon that raw image, we can arrive something. We can get some information. What is it about? What is that location showing? What is that region showing? So we can get that information from that cell. Like DEMS. DEMS is nothing but which we will use very frequently. Digital elevation model means here in DEMS all these cells will give elevation. Okay, height from the elevation is nothing but height, ground height. How much is the that natural ground height? Okay, so each cell in DEMS it will give height. How much is that height? What is the like high area is there, low area is there? So in that way you can find out that is nothing but a raster data. Now vector data, coming data. What is the mean by vector data? Vector data are points or polygons representing information of real world like buildings or roads. So how it is different, like you might be thinking it's one and same. No, this is a difference is there. So this is raw data. We will not able to understand quickly what is it. So okay, you may think in a raw way, we may see the colors something, but we cannot able to see black and white colors will be there. So afterwards we will analyze these things, then we'll try to convert those things into this form, vector form. So that is nothing but vector data. So real world things are buildings, roads, so those things. So we try to analyze those things. So whatever that resultant image, that is nothing but vector image. Okay. So these are all the things which we'll do. These are basic two terms which you're gonna hear if you are coming into GIS industry, like if anyone of you are interested. So these are the important things, basic things which you will be knowing, which you should know. Okay. Raster data and vector data. Okay, next man. Now, I think GIS and projection system. Now, projection systems you might be knowing, like the whatever the data like satellite images which will be they will be sending back to Earth's surface. Those should be defined. First of all, when you start using in GIS environment in GIS software, we need to define that what projection system are there, because Earth's surface is not flat. Okay, Earth's surface is not flat now. They will take images. The satellites orbiting around Earth's surface, they will take images and then they'll send that images to back to Earth's surface. But we need to again define that when we start using in GIS environment. First and foremost step is that we need to define what projection system is there. It's there. So this projection system will get from the depends upon the location. So for example, like for our India, most probably thing WGS 84 is being used. WGS 84. Okay, world this geographic system. I think world geographic system. If this is the system which we'll use normally in generally. This is global coordinate system. WGS 84. It's been used. Now projection coordinate system, when it gets projected, it will divide it like different parts. So this is a projection coordinate system. We need to define for analysis purpose. We need to do this projection coordinate system. Okay, before pre-processing itself, these things has to be defined in a GIS softwares. You might be seeing, if you I don't know in your college if you are being exposed to QGIS or not. These are open source softwares are there. You can directly download and you can use. But before that, you need base layer, which from satellite members, which you can download. If I get time, I'll try to show you how we can directly download. It's freely available softwares like images are there. You can use that image and try to analyze these things. So these are the two projection systems. Next. Next slide. Okay, these things. So these are the these are the different steps which are normally which we use it for our hydrologic purpose. Now I have previously explained this. What are the different problems which you try to flooding or these things which you will try to solve using in hydrologic field. So what are the tools that are normally used daily? There are GIS means it is used for different purposes. Not only in hydrology, GIS is used for different purposes. For real estate also it's being used. Real estate, how real estate is growing, we can use it in that way. But for in hydrology, what are the important tools which is being used? So these are the different steps which are normally will use frequently. Georeferencing. So first of all, if any raw image is there, we try to georeference. For satellite image, it's okay. We can directly take up and it's already georeferenced. But for example, if you have any raster, any other image map, like a topo sheet is there. A topo sheet means Survey of India topo sheets will be there, which has its own coordinates, those things, latitude, longitude. So those kind of pictures are there, some latitude. So then we need to take it into GIS environment. Then we need to do this georeferencing step compulsory. Means there we need to take 4 control points. We need to give 4 control points. Based upon that, it is georeferenced. Okay. So when you georeference means it's representing an area on the Earth surface. Okay. So you can when you do this georeferencing, then you can fix it to a certain area. So based upon that area on that GS environment, you can directly calculate. For example, if you measure an area, you can directly draw a figure like a closed figure is there. You can draw a polygon. It will directly give an area. But we need to do georeferencing first to get that area, like a total area. What is the area is there? We need to before that we need to do georeferencing. Next, catchment area delineation. As I said before, catchment area is one of the important thing we need to find out. Like if you are planning a new project or new for a existing project is there. If you are studying for a flooding or this thing, we need to know what is the catchment area. What is the area that is contributing to the flow that outlet point. So for that thing, you need to know this catchment area. How much is the square kilometers? How much is the area that is being contributing to the flow? So that is being done within catchment area delineation. This is one of the step. So here in this step, what it will do means normally we'll try to feed input DEMS. DEMS, as I previously said, in DEMS it will give and each pixel it will give elevation at that point. Okay, elevation on the ground at that point. So that DEM is used as a raw image, and then it is being converted into what you call raw means raster image into vector form, a catchment area. Okay, so based upon there are many steps will be there you need to do. Then we'll get catchment area. What is the catchment area? So you can see based upon the elevation. So water flows from upland area to downland area, upside to upper level to down level. So the each pixel will have its own elevation. Okay, so one pixel will be having at a height of 10 meters for suppose. The other pixel will have 9 meters. So in that way, from 10 meter to 9 meter height, I'm saying. So the water will flow from 10 meter to 9 meter elevation point, not from 9 meter elevation to 10 meter. Okay, you are able to understand. Water flows from high level to low level. Okay, so that is the basic concept behind this catchment area delineation step. I'm just trying to explain briefly. If I was there in like directly on board, I could have explained briefly, but this is the catchment area delineation. This is basic concept. So next, image analysis. Image analysis, as I said, when we have a raw image, we need to see how much, what is the information it is giving, like what kind of area is there. It is forest area is there, or is it agriculture area is there, it's urban area is there. We need to know it before, because urban area may give more flooding. If it is urban area is there on the upstream side in a catchment area, if more urban area is there, for the same amount of rainfall, it will give more runoff. Okay, if forest area is there in the catchment, for the same amount of level, it will give lesser runoff. Okay, so this image analysis, what it will do, it will help It will help that directly. Like instead of going to the field, we can download the image, raw image from the satellite, and we'll look at the image and we'll see how much area that is covered with the forest, how much area that is covered with urban area or agriculture field. So this is all the things which is being done with the help of image analysis. We'll give different colors, those things. Land use, land cover. This is one of the application of the image analysis. Land use, land cover classification. We'll try to classify the different land uses, like as I said, urban or these things, or soil type also. Which is the soil type? How much is the soil that is used? That is clay. How much is sandy? So that can be used. Okay, next. Okay, till now, is there any doubts or something you can ask? I can see there's 23 people are there. If you can ask anything in between. Yeah.
Good evening, sir. My name is Kalyan.
Okay,
I'm from
Kalyan.
final year.
Yeah.
I just have a doubt, sir, regarding the previous slide.
Yeah, you can go back, madam. Previous slide. Yeah.
Sir, in this, we use this tool called flow accumulation in GIS, no, sir?
Yeah. Flow
So,
accumulation.
do we use this flow accumulation tool before designing, or we do it for survey after designing and constructing the structures, sir?
Before only. Like for example, if you are planning a new project, is there, like government tells that let's plan a project at one location. Like government, like some people will come around, like farmer peoples are there. Like they will say that here are some, okay, ఇక్కడ ఒక చెరువు ఉంది, ఇక్కడ ఒక నాలా ఉంది, ఎప్పుడు నీళ్ళు ఇక్కడ నుంచి వెళ్తుంటాయి. They'll say that, for let's suppose. So then they don't know how much area that is there on the upstream side, how much area that is flowing from the upstream side. That's catchment area we need to know. So flow accumulation is one of the step in catchment area delineation. Okay, GS మీ యొక్క steps లలో flow accumulation is one of the steps. There are many steps that will be there, like finding out slope. These things will be there. So out of all the steps, one of the important step is flow accumulation.
Okay, sir.
Yeah, for finding out the catchment area, it's useful in GS environment. You have done somewhere?
No, sir. I'm actually learning the software.
Which software you are learning?
I'm learning ARC, sir. ArcGIS.
RGS, yeah, RGS. Okay, RGS is a wonderful tool. QGS, it is a little bit cumbersome. You have many steps. RGS, with RGS you can do. You know, college you have RGS?
No, sir. Our college teaches Q, but during this lockdown, I'm learning ARC.
Okay, good. You learn. If you are
Actually, sorry
RGS,
for the interruption.
yeah.
College is having ArcGIS, so licensed version, but it is not supporting spatial tools, spatial analysis tools. Only basic tools, basic version is there.
Okay. Basic version is there. Okay. But still, you can talk with the RGS people. They can upgrade if you need. You can upgrade. You can call up. They will give service also if it is in the period. Like when you have bought, I don't know if it is in warranty period. Like some period will be there. If you can call up, they will help you out.
Yes,
Okay. Next, is there any other questions? Yeah. Like whatever you can ask. Like I can answer anything. Like means whatever I know. Even I would also like to learn. I don't know because I've completed my civil engineering long back. So
Yes, sir, this is Somo, sir. Good evening.
Somo, okay, good evening, Somo. Tell me.
Sir, can you explain about that Kondapochama Sagar? I saw there are irrigation and CAD department in that.
Yeah,
Yeah. Can you please explain that?
Yeah, it's one of the new upcoming new project only. It's one of the what you call. It's been it is Kaleshwaram. It's a part of a Kaleshwaram lift irrigation scheme.
Yeah.
For that, I need to explain Kaleshwaram project. Kaleshwaram project is planned in such a way. It's wonderful project. Why it is wonderful project means, see, the Godavari River, as I said, it's flowing from like Maharashtra. It flows through. It crosses different Karnataka. Then it will join. It will come into our Telangana. then it will go to like AP, and then will finally join to Bay of Bengal. The problem is with the Godavari River, at least for our sake, is for our Telangana, is that the main river, whichever it flows at far lower level. Okay, at far lower level in comparison to the Telangana level. Telangana is at a little bit most of the topography is at higher level. Most of the land surface which is at higher level. Okay, so it flows at Adilabad, as it starts from Adilabad district and Karimnagar. So those districts flows, and then finally it's only for small area it flows through Telangana, and it goes through AP. So the problem is that we have excess amount of flows in Godavari River. So in Krishna, we don't have so much of excess flows. Krishna, we have used it up. We have constructed so many big projects. NSP Nagarjuna projects is there. Jurala is there. So Srishalam is there. So these are big projects. We have consumed whatever water that is available in the Krishna basin, and we are using that. But in Godavari, still there are water that can be used or it can be tapped. So what our government has done is that they have selected a location from where we can lift the water. Okay, so they have planned this Kaleshwaram lift irrigation scheme from that location. Okay, so that location, which is at a little bit lower level, from that they have constructed three barrages. Three barrages are there. Lakshmi, Saraswati, there are three barrages are there. So what this is called as reverse, what is that's called as reverse engineering or some kind of they have used the term, but they have elevated that water flow to a higher level. Okay, it's a lower level, Godavari actually. So they have with the help of these three reservoirs. Okay, Lakshmi, Saraswati, some other reservoirs are there. Three reservoirs they have constructed near that Godavari River in Adilabad district, nearby Kaleshwaram, exactly Kaleshwaram point. They have constructed three different reservoirs, in three different levels. So they have increased it. So in one reservoir, when it gets full, from there it will lift it to another reservoir, which is at another higher level. Okay, then afterwards it's lifted to another reservoir level. Okay, three series of reservoirs. So finally, when it reaches the higher level, from there water being supplied through gravity only. Okay, so this is being done in a different way. It's never been done. Okay, normally water flows from higher to lower elevation. So what we have done, we have increased that elevation there only at that point nearby Kaleshwaram. From there they have constructed three reservoirs, so they increase it to higher elevation. From there it supplies to now. Before that it used to flow only in small area, 2-3 districts. So here from there they are picking up the water. Water means excess water is there, and then it's not that they are planning a reservoir or something. They are just planned a network of reservoirs, so that the water will start flowing through this Telangana also, through these districts also, Medak. So these are all districts are there. So Gajwel. So I think Kondapochama Sagar is I think Gajwel or Silsila. I don't know, Gajwel district. So it's one of the
near to that Gajwel.
Okay, somewhere it's location. So in that scheme it lies. So this is, and that is it has garnered at what you call this in public because it is being surrounded. It's in between there is some island formation. It's being naturally it's formed. So that's why it's been like people are being interested in that Kondapochama Sagar, I think. So that's why it's good. It's good if you have anytime you went. I think many people are going in between nowadays. It's
Yes, sir. Recently I went there. That's why I was.
Yeah. It's good for viewing. I think even I didn't go, but I have heard that. Okay.
Yeah, sir. Thank you, sir.
Okay. Yeah. Still anything? Any doubts? Yeah. If there are any no more doubts, then I can continue. Okay. So this is one of the case study. I'll try to explain this case study of like recent floods, recent Mulgu floods. What are things which are seen in the pictures in before. This is somewhere that photos. The NH highway you have shown now, NH 165. This here in between there might be some NH 165. it's I'm not able to see, but here there will be that road. So completely it got submerged because of that continuous rainfall. Okay, because of continuous rainfall. So this is the area. See, this is how I have delineated. You can see this is the base map. Here is the base map. This whatever this is in orange color, orange or light red color, is being delineated. I have used it delineated in a different software, not GIS environment, but it's an open source Google Earth engine. As I mentioned, Google Earth is upcoming software. It's new advancement. So based upon that Google Earth engine only, I just what I did what I did in that I have just kept the outlet point. I have given, okay, I want this area, whatever area that is being drained. Okay, whatever draining area to this point. Okay, so I just want this. So I have given that outlet point in that software in that Google Earth engine, and it automatically it will give this boundary. It has given this boundary. This is the boundary. Okay, this is the boundary. So this is the total area. So this is a Jampanna Vagu. I try to see what is this Vagu. For example, I want to see this flooding is taking place. This is the flooding area. So this is the Jampanna Vagu. So this Jampanna Vagu is flooded totally. So I'll try to analyze that. For example, I have started to see. I started to study these things. What are the reservoirs are there nearby? Okay, this Ramappa Lake is there. Okay. No, this is another famous place will be there here nearby. If you can zoom it. Yeah, this is there will be another reservoir will be there. So this is also flooded. This is also flooded because of the continuous rains. Okay, so because of this complete highway got flooded. Okay, so what are the solutions you can offer? Okay, of course, continuous rains have happened. This is happen. These kind of rains are not seen in recent times. It's once happened, I think, about 30, 40 years. That's higher intensity of rainfall. So remember, every time when I say these floods or these things, it doesn't occur simply like we need to continuous amount of rainfall, and that too higher intensity of rainfall. So intensity is different. Rainfall, like normal rainfall is different, and intensity is different. Like you'll be listening, you'll be studying the rain gauge type. You know, you will be having a rain gauge type. What are two different type of rain gauge? Recording type and non-recording type. So non-recording type, what it will give? It will give only the rainfall which is occurred over the whole day. Okay, total day, how much rainfall that is being occurred in that rain gauge station. But recording type, it will give a graph, finally a graph. So how much intensity of the rainfall that is being occurred, how the increasing of the rainfall. Like for example, every time the rainfall is measured at morning 8 o'clock. They will go to the rain gauge station and they'll see how much depth of the rain is occurred. That is nothing but the rainfall. Like they'll say 100 mm, 10 mm, 20 mm. They'll say that those are the depth of the rainfall that has been accumulated in that rain gauge. Okay. So, but in recording type, it's not only the 8 o'clock rainfall. We'll get throughout the time, like afternoon 12 o'clock, I need rainfall. How much rainfall it is increased? Suddenly we'll see higher increase of rainfall in between. So suddenly it will fall. So that graph also it will help for us. So suddenly this sudden amount of rainfall, it will lead to flood. Suddenly, for example, higher amount of rainfall has occurred. If you go and capture, if you go and see in the morning 8 o'clock, see, then if it might have reduced in the night itself. So in night it doesn't rain. So we'll see only average figure. So that's not useful. So that's why recording type rain gauges are useful for flooding purpose. So we can see that at what time it has occurred, how much it is increased. So suddenly in a span of 1 hour, if it is a high amount of rainfall, so it may lead to the flooding like 1 hour, 2 hours, 3 hours. So those are the things. Of course, in this case, it's continuous 3 days, 4 days of rainfall. But in some cases, like I said, a Kadam project is there, Kadam irrigation project, which it's located in a very dangerous terrain actually. So there, if it's continuously, if it rains for 1 hour, 2 hours also, it leads to flooding. It flows. The Kadam will completely, it gets full because of that slope. Suddenly, within 1 hour, 2 hours of rainfall, it gets flooded. So that's why how these different parameters will come into the picture in studying these things. So there we'll monitor so closely. that project, Kadam project, how it is getting filled up. We'll try to see daily, we'll try to see daily, hourly also, we'll try to monitor that project. Okay. So this is one of the case study which I have done, and this catchment area I have tried to measure, and it in the software it has come about, I think 1200 square kilometers. I think in coming slide I think has that data. You can go to the next slide, man. Yes. See, this is the one of the flooding. You can play this if possible. Flooding in Mulugu. This one you can. This is a hyperlink is there. Yeah, this is Mulugu is which is Estpal district. Yeah, you can click that. Yeah, this is I think you must be knowing her. She's Sitaka in that constituency. MLA of that constituency, Mulugu. She has walked through all through that highway almost. I think she has noted, explained flooding. Okay, I think it's not clear. Okay, that's just I wanted to show. Okay. Okay, this is the flooding in Mulugu district. Now, this is the catchment area, which I found about 1600 square kilometers. So that area which is marked in red color, na? So that is the area which is contributing to the flow at that point. It's total area. Okay, so we will not get flows from the other area. That only that boundary area which is being causing the flood, like continuous rain. This is being noted continuous in the catchment, filling all the lakes. Like there are lakes are there, many lakes are there. So it's being full completely. It's got full. So NH 163 got completely submerged. Solutions. What solutions you can offer? That's it. So you can see there is a primary big highway that is being passing through that area. So that's why you can increase the maximum water level of the bridges. There are existing bridges are there. So you cannot submerge the bridges because it will lead to the transportation problem. National highway means it will, this highway connects from Telangana to, I think, Orissa. I think this is it. So it connects. National highway means connects different states. You cannot stop. You cannot submerge. You cannot allow submerging on that national highways at least. So that's why you can increase. You can plan increasing of the maximum water levels. The whatever that pillars or piers are there now. So that slab which is being laid, you can increase that level of that those things. That is one solution. Next, flood inundation area should be clearly demarcated. Next, of discouraging from construction in floodplains along the streams and rivers. So in that there are stream networks will be there. Stream networks, rivers will be there. So what happen in case of floods? It will start overflowing from the sides, banks, left bank, right bank. Okay, those things, those areas will get flooded. So in this now scenario, which you try to clearly demarcate. Okay, this is the area which is getting flooded. You should discourage the people from doing any kind of constructions in that activity. Because if you construct in that, like if you construct buildings or something, ultimately it will lead to the loss of property. It may lead to the even life also. So that's why you'll try to clearly demarcate that this is a flooding zone. You can clearly say this is a flooding zone. You should avoid. Government should say, you can say this is, you should avoid any constructions in that area. So those things. Next, other solution is that you can construct new structures for flood absorption. I think you are not able to see that, but that simple thing is that you can construct new structures, new small structures. You cannot construct big dams, of course, but you can construct small check dams or small structures, which will at least it will reduce that flow of the water. So in between on that streams, small streams, you can construct small check dams or these things, which will try to reduce that flow. Okay, so that it will reduce that impact of that flood. Okay. Next, so these are the few suggestions you can do. Next, this is a Google Earth engine. Next, HECRAS. Okay, I'll try to open in my area, in my these things. Can I screenshot? Can I? Okay, I
Yes, sir,
think.
I can stop sharing. Then you can switch on to your Google Earth Engine and HECRAS.
Yeah. Okay. Let us see if it is possible. I can able to see that at that time also I may face the same problem also. Now you put it in share.
And share.
Yeah. Let us see. I will try to share it.
Then that is good, no?
Yeah, I will share. I will share. I will try to see. In between also, you can ask the participants, I think students, if anything.
So you can share now. I stop.
Yeah, I will share. Yeah, you can able to see.
So it's still not connected.
No, sir.
Yeah.
Use that option, sir. Share option.
Yeah. Wait. Share desktop. Yeah. Now it's okay. Now you can
Sir,
see.
here one desktop option is there and upper is there open share tray. Can you if you click on that one, you can share your desktop, sir.
Yeah, that's what I'm saying. That's what I'm not able to see there. Where it is there.
Yeah,
So
here down, sir. After speaker, you had one
arrow
symbol.
mark. Arrow
Click
mark.
up arrow, sir. Up arrow mark.
Yeah, start sharing is there.
Yes,
Okay.
sir. Once again, you need to click on that.
Desktop. Okay, desktop. I think now like you can able to see.
Yes,
Yes,
sir. It
sir.
is loading.
Yes,
Yes,
sir.
sir. Yes, sir.
It is.
Yeah.
It is visible.
Last time also we can do this thing. I think. Okay. Chalo. This is Google Earth Engine. If you are interested, I really recommend this. I really advise this. You take this. You note this Google Earth Engine. So this is the website code.earthengine.google.com. For this, you don't need anything. You just need your Gmail account. Simple, you can sign in, you can get registered. Okay, so you will get your account. In that, you can work it out. You can work out freely. You will get all the satellite images, all this on your own, like in your account only, not on your system. Okay, this is a free software. It's like a software only. It's not exactly software, but this is software which you'll use for coding. Okay, so this can be, it's a nice platform. It's coming new advanced, you can say latest these things, from where you can do different kind of things without the use of any GIS software. You don't need to learn any RGS. You don't need any QGS. Nothing. Okay. Although for few things I'm saying, although you may need some other steps, like some other steps you may need, but for the things which I will show, you don't need any softwares. So here, how we can do is that, like this Jampanavagu is there. Like for example, I have this Jampanavagu. You can able to see this. This is, here we have different what you call interfaces, these things. Here you will have this your files, whatever files you have worked on. Okay, now here this is different documents which you can import. These are assets means directly you can, whatever, if you are done in GIS environment like QGIS or ArcGIS, you use shape files. It's called as shape files. Actually, shape files means vector files only. So those things you can directly import it. Okay, import it on the Google Earth Engine and start working. You can start working like this. Like for example, I'll show you Kadam, these things. Like Kadam will do the study. Like I have done this Kadam project. I'll show Kadam catchment area. Let's see. Yes. This is Kadam catchment area. See this. You can able to say this is the Kadam catchment area. This shapefile I have got from the same Google Earth Engine software. Of course, it's not that exact. Why it is not exact, you can see. See, where is the Kadam project? Here it is the Kadam irrigation project, Kadam Dam actually. This is Kadam Dam. Now you can see these are this is the area which is contributing to the flow to this outlet point. I have given this as an outlet point. Okay, this should come to till here only, but it has given a little bit excess area. Okay, so this is the shapefile. This is called a shapefile. Shapefile is nothing but you don't need to get frightened by these terms. I think shapefile, vector data, raster data. These are new what you call frequent terms which you use it in GIS environment. Shapefile means whatever the file which will create on the GIS. Okay, so this shapefile means like you can draw. You can draw with like in paint you will be having pencil. You can draw now. So like that in GIS environment you can create a shapefile. You can shapefile or will be having it to it's different types will be like you point or polygon. This is a polygon shapefile you can say. So this is being delineated automatically in Google Earth Engine. Okay, this one I got it. Now this one I have imported. Okay, imported into Google Earth Engine. Now afterwards I would like to see the rainfall in this area. Okay, so the rainfall. So for this purpose, what I have done is that I have taken this chirps data. Chirps means it's a satellite. Okay, this is chirps. You can see this is chirps, one of the groups of satellites which actually monitors the daily rainfall. Okay, this is software which will monitor daily rainfall all over our Earth surface. So with the help of that thing, I am able to get the rainfall data directly. I don't need to go any other way. Normally what happens is that when you do water resources projects, water resource studies, we'll be having this lack of rainfall. We'll suffer from this. But here from the satellite itself, I can get this precipitation data. You can see directly. I have given this dates also from here. I can give what are this 40 mm rainfall. This is rainfall is 0 here on June 17th. July 22. See, this is the rainfall. July, it was rainfall. So it's 1 month lacking. I wanted to show actually August rainfall also, how the rainfall was there. But it takes time for the getting processing that data. So it might take about 10 days or like that before getting that previous month. Like we are in September. So we need August data means we need to wait for till about 15th or 20th September. So 15-20 days it will take for processing that image. Okay, so based upon that you can do a lot of things. Here I have written code. See, this is the code. This is small bit of code. This is code you can directly write. Simply variables. I think normally you might be heard the C language. You use C language. I think like that only. It's a code. So small code. So here I will write the filter date like June to August. I have given that data. Now I can change this date directly and I can get this in the graph format. Not only in this graph format, I can download this directly in CSV format. CSV format is nothing but Excel only. Means you can convert directly into Excel and day wise I can get the rainfall. Like in a day, particular day, rainfall. 2 columns I will get. Yes. So this is a specialty of Google Earth Engine. Now, if I need, for example, see Usman Sagar is there. Usman Sagar also, see this. We can directly see. You can run. So this is wonderful actually, and it has its own programs directly built in. You can just browse it and you can see there are different kinds of these things are there. See, this is I think Usman Sagar and Himat Sagar. You can see these are the locations. Himat Sagar. I think here somewhere your college will be there, no? Vardhaman College will be there here somewhere in the Himat Sagar catchment. Okay. Here somewhere I think. So you can study the how this is gonna like different land use land cover will affect the flows at this in the reservoir. You see this is a different ways. This is satellite image. Actually, you can see this is pure raw image from the satellite. This is a different and from here you can you need to understand by giving different colors. This is being colored by using program, of course. So this is a city. This is Hyderabad, our city. No, this is Usman Sagar. Basically, this is an Usman Sagar. This is the Usman Sagar reservoir. So this is the total area. No, this is not the rainfall. I have studied for NDVA. NDVA means it will give the vegetation index. Normalized differentiation vegetation index. It will give the how much is the vegetation pattern, means what are the healthy vegetation is there, what is the cropping type is there. So those things I have studied with that. I try to do this. So there are different things are there. This is these things, and for this I have used the software. I have extracted the image from Sentinel. Okay, Sentinel is also one of the group of satellites. As I said, Sentinel also group of data. Of course, you can download these images on RGS. You can do the same things on RGS also. This is Sentinel group. This is also you can download directly. This is a group of satellites where you get different kind of datas. That this is open source. This is directly, you don't need to purchase or anything. You can directly do it. You can directly take it out and you can do on your QGIS or RGS. You can use it as a layers, as I said, and you can start working. And you can see what are the flow pattern, what are the things which will influences our land use, land cost, all these things. These are the different applications of, you can say, GIS environment, all this. But you need a little bit knowledge about, of course, these satellite images, these things. But if you are interested, then if you start working, you will get it. It's not a big deal. Small things only. When you start working, you will get it, everything. So anyway, water, it affects us directly. Although we'll try to neglect it, but it affects us. But we don't know, and unknowingly we'll try to we'll see that so many ways water plays an important role through irrigation, drinking water, whatever way it might be. So we need to study. This is one of the important field, of course. So in that way we use, this is one of the way we can do it. Just wanted to show. Any other these things you want to ask, you can ask. Now you are able to see?
Yes, sir. Your presentation is visible.
Okay. I could have done this before only. Okay. So you have any other doubts, you can ask. You can share these things. This is Godavari River basin I was talking. Okay. Any other doubts? Any things?
Sir, I have one doubt, sir.
Yes.
So what you have just shown us the image, satellite images.
Yes.
Chips, is it freely available?
Yeah, it's freely available.
Open source only.
Open source only, freely available.
What is the spatial resolution, sir?
Spatial resolution is 0.15 by 0.15 degrees. I think 0.15. It's highly, what you call, it's more accurate than even this RG stations also. Because in RG stations we have in mandal, every mandal will get a rainfall data. But mandals also very, it will be at a distance.
Okay.
So 0.15 means it's nearly, I think, 5 kilometer or 3 kilometer. I think 5 kilometer or 3
kilometer. We get raster data, raster image of rainfall, right?
Yeah, we'll get the raster image. We'll get raster image values. Yeah.
Previous means historical rainfall is available, sir. Is it newly available?
Historically from 1980.
1980.
Yeah, 1980 to present. You can get 30 years of data. It started in 1980.
So it is what is the format of rainfall, sir? Daily or hourly rainfall?
Daily. Hourly you will not get. You will get daily.
Daily. Shall we take these grids, raster grids, into the SWAT directly?
That I don't know, but I think that I have no idea. I didn't try. I had tried on directly Google it only, but it might be. I think you can use. I think because if it is a raster available, it is in raster format. You can use. I think on GIS environment also might be because Sentinel will use Sentinel as I showed this one NDVI which you have studied. This I use it on Google and Google Earth Engine also, and also in QGIS and RGS also. So this is a raw image which I use it in RGS and QGIS also. So I think chips also it can be used directly. You can download from the website and you can use those things. But I didn't try that. But this is wonderful. This is you should try. I think Google Earth Engine. This is wonderful. You don't need to go through all these steps. You need only this code actually directly, and these codes also openly available. This is not even I haven't done. I have taken these few steps and I use it for this area. You need to select the area, whichever area you have studied for your area.
Code, is it Python or C?
This is Python.
Python only.
I just wanted to explain to students because in BTech we will have only C language.
Okay.
So normally the pattern will be having a syntax, a variables. So this is also similar fashion. I just wanted to give this. See variables. These are all variables. We'll try to give assign variables, and in that fashion we'll try to give add layer. Same way like in GIS we'll having that add layer. Those in RGS we'll having those things. So those kind of steps we'll do by writing in Python. So
okay. Shall we can do the modeling here?
not modeling completely. That's what I said. Now it's we can do spatial whatever things, but we cannot do complete modeling like complete it's still new. Maybe it's being done. People are still working. So maybe in future it may be used for modeling also. So people are still
NDVI, I know, sir. So does it give the report, physical report of that?
Yeah, you can download it. Like for example, if you want to download it to your drive and you can download it to your drive. You can download it to your Excel. Like I said before that I have showed that CSV format. So chips rainfall data is there. Na? Previously I have showed. See for example. So this one when you run this. Okay, given this as this one. Let's wait. August. It's see. You can see the image collection is empty. It's showing. Means the satellite image which is being collected. It's not being now processed yet. So that's why it will show that error because August rainfall is not available yet. So you can change this simply. See, I don't need to do any kind of separate analysis. Now I need July only, for example. I'll again run it, rerun it again. See, I got the chart now. So this chart, you can simply download this as a CSV. You can click it like this. So you will get it in a CSV format.
Okay. At a time, how many days we can directly work on it?
I think you can get there is no limit also. I have tried for 10-15 years also. You can get it at I think even for example, let's see if you asked so let's see okay, wait. You can get in a chart only, na? There's nothing problem. For example, 1990, let's see. 1990.
Sir,
1990.
giving with respect to the rain gauge stations already, IMD rain gauge stations?
Not rain gauge stations. It will use based upon satellite.
Okay.
But it will try to, they are saying that it try to correct based upon the ground data also. But whatever I have seen that I have compared with the physical rain gauge stations, and it's giving less than 10% error. Error means it has its own resolution now. So it will not be same like these things. In fact, it might be more accurate than these things also. These are rain gauge stations.
Even IMD.
Yeah, even IMD also. IMD is in fact the resolution is very poor. We have our state MRO station. In every MRO station we have RG stations. So those are more higher resolution. but IMD you cannot compare also. But here, what you call, you can use it for your study purpose. But for floods, what I see in few papers, I have seen that for floods it cannot be used, but for water availability you can use, because on an average basis, it's showing it's satisfying.
Okay.
The error, it's, for example, you are taking 10 years or 20 years of array, of rainfall, it's matching, you can say. But predicting exactly same value, like for example, I need rainfall on 15th August. So 15th August rainfall, if you want Hyderabad rainfall on 15th August, and if you have a rain gauge data on 15th August, it might not exactly match. It might give a little bit different value on the this chips data. So spatially, it may not, like on a location basis, it may not give perfectly. But overall average, like for example, if you take over long periods, it's I have seen few papers that it is giving good results. So it's a new thing. Till research is going on, but it's many people are using this for studies.
That is the problem, sir. Why? Because when we plan hydrological projects and which are related to rainfall mostly, but we are not at all getting free rainfall data, even hourly. Hourly, it is not at all possible. Even daily, also, we are not getting. So when we asked IMD or other departments, even Telangana State Planning Department, so they asked us to purchase.
Mm-hmm.
That's
You
what.
daily rainfall you should get freely only.
No, sir. If you are asking for any 20 or 30 years, even at least 10 years, um, they asked us to purchase.
No. Telangana state, you don't approach Telangana state planning.
No,
You
yes, sir.
approach to Directorate of Economic Statistics.
Directorate of Economics and Statistics.
There only, same office. Beside that, you can write a letter officially from
Okay.
your HOD or from your whatever, like your principal or like this, from representing your college that you are doing for the study, not for a private purpose. Okay, you should
Only
mention
research and study only, sir.
research and study. They will give, but you should follow up. You should try to write mails continuously. You should try to call up. They'll give. I have just recently I got it. Just recently I have sent a letter. Even though they'll respond quickly only. It's not like they'll give freely only. For private people, they are charging, it seems, but not for research students. They are giving free.
That's what they said, sir. Actually, Telangana Planning Department. So ours is, they said ours is autonomous college. It is not a government organization. So they asked us to purchase.
Okay, this I don't know. Maybe this thing I don't know, but they have, whatever I asked, they said that we are giving freely only. But maybe because maybe autonomous this thing, maybe they might having their own this thing. So even if the purchase also, it will be lesser cost only. I think hardly, maybe very lesser cost only you'll get. I think it's not so high cost, like
No,
into lakhs.
it is not lakhs, but even greater than 10,000.
10,000. Okay. I
Yeah,
don't know.
tech people cannot afford that much, no, sir.
Okay, 30 years means maybe they might be charging more, I think. I don't know. For private people, they are saying for contractors they are charging. That's what they have said. I asked. They said that for contractors or these things they are charging. But even for research purpose, if you mention, I think there should be no problem. I think for research only now you are doing.
Yes, sir.
Yeah, you should
Definitely for projects only.
for research of these things only you can ask. I think. Let's you try and these things you try to talk and what are the, maybe there might be having their own policy.
Yes.
Policy, data supply policy will be there. So I don't know which how they are following. But for us they'll give. That's what. But monthly you can get.
Okay, sir. Monthly
Month,
averages, seasonal averages are there, sir, but we
yeah,
cannot go
monthly
for hydrological
monthly
modeling, no?
modeling. No. Modeling for what you are doing.
For suppose any flood forecasting or flood analysis.
For flood analysis means you need daily or hourly only. But
Yes,
for
ma'am.
water ability, I'm saying you can directly get the freely whatever that is there on the website. You can use. You can use directly because you don't need to go to also. You don't need to go to them also. You can directly get there in the down in the website itself. You can start working water ability. For flooding, of course, you need.
In Hyderabad, the current issue is a flooding only, urban flooding only. We thought of doing flooding, inundation, and then
Okay.
sustainability maps and then projects, but we are lacking of this rainfall data, so that's the
You
problem.
can do other methods also, no? You can do like observed data instead of going this. You can go for this isopluvial maps, CWC. These maps are there. Some what is the method called? Those isopluvial maps will be there. So from there you can get the maximum rainfall. From there you can start working.
Okay, sir, we'll try it.
Let's see.
Thank you.
Okay. Any other doubts? Any other things you want to ask participants? You can ask anything. I think even structures also you can ask. I don't mind. In fact, I wanted to explain some structure design also, but because this topic is relevant to GIS only, it's focused on GIS only, so that's why I wanted. Because I wanted to first initially start with structures explaining a structure design, and then I wanted to explain how when we neglect the water aspect, how it gonna affect. Because ultimately, if you plan a bridge, for example, bridge on a river, so you need to take into account the water also, how water that is flowing on the under the surface. Like there is a saying is there. If you neglect the water under uh, the bridge will be under water. So for any irrigation structure, for any hydrology structure, you need to study the first of all water only. So then afterwards you should go for structural design. So I wanted to just touch upon the structure, but that takes time, takes a lot of time. So just you cannot study only the loads, whatever dead load, live load, whatever those things coming on the bridge, and you can start working out. You need to take into account this water, whatever is flowing under the structure, whatever dam. If you are taking to dam also, how much water that's going to come and get stored on the dam. You need to see that load also. You need to see those things, gates operations. There are many topics are there. So I just wanted to see glimpse this thing. I just wanted to give a glimpse of GIS environment and hydrology problems. This is a of course, if given an opportunity, definitely I'll try to give another lecture with more descriptive these things. But this in this way, this is the first time actually I interacted in this platform. So I hope I haven't I have tried to explain properly. I try to, but still forgive me. Anyway, but it's okay. Don't know how to respond, but it's okay. Okay, come. You can ask any other things. Any other things which you want to ask.
Sir, this is Kalyan again.
Okay.
Sir, what kind of placement opportunities we will have through this GIS software, sir?
Okay, that's a good question. That's a good question. I think ultimately what happens, like if you are in final year, Kalyan?
Yes, sir.
Okay. See, the industry outside is that what happens is that it will be changing continuously. The technologies will be changing. The fast changes are happening. You need to always will be, you should be up with the market. So market, what it is being demand, what are the things it is being seeing. That's the thing. Like whatever things. Like for example, I'll always say that like a typical shopkeeper, you'll go like Kirana merchant will be there now. You'll see, you might have seen in this pandemic only how a typical small conventional Kirana merchant has evolved suddenly. He started to get all the things from the mall, like whatever the malls which are being closed, he started to supply from the Kirana itself. So I just wanted to explain in a different way for giving an exciting example. But see, due to the pandemic, these things, the jobs are getting decreased. These things, the unemployment is on the rise. Those things. So, like you're asking particularly GS environment. So, like if you are seeking an environment in any other software companies, there are many companies are there, software companies. You need to browse, you need to go through. RGS itself has its own branches here. Okay, RGS like software, what software will work on, they have their own branches here, RGS. So you can apply there also. But
Hyderabad, sir.
in Hyderabad only. So they have
S3.
base ISRI based office will be there. So their technical people, some will be marketing people will be there, some technical people will be there. So in order to apply there, you need to have that background, GIS background. You might go through their lectures, you might go through some GIS certificate. There are online courses are there. Okay, RGS itself, they offer certain courses, RGS courses. They'll charge about 500 rupees, 1000 rupees like that. Okay, it's a lesser cost only. So you can practice based upon that only. If you have RGS software, you can take that course and you can get a certificate also. So there are many things are there nowadays. Internet is there, so you can browse those things. There are many places where there are many they are offering courses, free courses, and you can practice. You can get certificates. Free courses, you don't get certificates normally, but certified you can prove, and you can get the tools also. You start practicing. That is the thing. You start browsing and practicing. There are many websites are there, so you can go through. There are free tutorials are there. Many free tutorials are there. So whatever the things which are applications point of view, see, ultimately you should able to solve certain problems. Those things, what are the things which you are going to solve, what interests you. So those things you should try, and you should pick up that field. Like flooding is a problem. Okay, water ability is a problem. So this is one of the flooding. If you can able to focus on flooding, so what are the things are needed? What are the tools? What are these things you need to study? What are watershed delineation? These are steps you need to do. So you need to learn. QGS is also you need to learn. So that if you, before applying itself, if you show them that you are interested in that, by that I have attended in so many sessions, I have attended, I have taken these courses. So if you can able to show in your resume you can able to show with the certificates these things, then they'll have no problem in hiring you. Okay, Kalyan?
Okay, sir.
Okay, just be in touch with the market. Just stay in touch with the market, whatever those things, the latest developments that are happening. To all, I'm saying to all, just be in touch with the latest developments, latest softwares, even coding also. Coding also, it's like happening like a fast. It's taking, like, you don't need to like stick to the only like typical civil engineering thing. I will not touch coding. No, no, no. If you learn Python, these things, it will be useful only. In fact, even GIS environment also, ArcGIS have its own Python code. ArcPy is there. There is separate extension is there. QGIS also, Python code also there. So if you have Python background, then it will be very much useful. You can show them also that I know Python like this. So nowadays there is nothing like a civil or mechanical or a GIS or like different this thing like computer science. No, if you have good technical knowledge of civil engineering, and if you have coding like what computer science people will offer, then it's a deadly combination. It's a deadly combination. Then people will hire you like anything, because computer science people are like blank people, like they don't know anything about technical knowledge, although they know computer programming, but they don't know these things. So if you can able to combine these things, then they'll hire you happily. They will hire you.
Okay, sir.
Okay. Anything more? Participants, I think. Anything
Okay,
more
sir.
from presentation?
Students, if you had any queries, you just ask. If you had any doubts regarding presentation or any details you require, you can ask, or otherwise we'll wind up the session.
Yeah.
Okay. Yeah,
Okay.
ma'am, can you give your vote of thanks, ma'am?
I would like to express my sincere thanks to Mr. Vamshiraju sir So on behalf of our civil engineering department, Bardhaman College of Engineering.
Thank you. Thank
Uh,
you. Thank you for the opportunity.
Enlightening speech on key skills on the hydrology, applied hydrology, and in real-world problems in solving the hydrological problems, and other technologies available to solve those the problems in the water resource engineering like GIS and then Google Earth Engine. Thank you so much, sir.
Okay. Thank you. Thank you. It's my pleasure. Welcome.
Sir, thank you from behalf of students also, sir. It was a interesting lecture from you.
Yeah. Okay. All the best to all final years. Just stay touch with the tools, whatever softwares, just learn. And I don't need, there's no problem. Just
Sir,
be.
one more thing, sir, I wish to convey you. So, if you have any time, then can you please present the process of HECRAS?
HECRAS, yeah,
Yes,
I can.
any example, a live example, I think any 1 hour session for students.
Yeah, I can give. But now you want me to continue, or you can? I can show you a little bit about. But I can give you interface. That's it. But I don't have any done example right now.
Oh,
Yeah, but I can
yes,
show you that.
I'm asking for any, you can take any live example for entire processing from starting to ending, how a project can be done in HECRAS environment.
It can be done, but it takes about another 15 minutes, 10, 15 minutes. Is it okay?
I'm
Is it
not
okay?
asking now. So in
Mm.
future, if you are willing, then we'll keep in touch with you.
Yeah, I'm okay. I'm okay. I'm no problem. Happy to.
Thank you, sir. Sir,
Okay.
I'm over to HOD, sir. Anything else to say then?
Yes, sir. Thank you for your valuable presentation, sir. Our madam and students will touch with in keeping, sir. Sir,
Yes.
whatever the students require,
Yeah.
we'll sort out those topics and we'll approach you, sir. Whenever you are free, you can take one or two lectures for our students regarding that GIS and what the madam had requested from our department side.
Sure, sure.
If you're free, you can. Thank you, sir. Thank you for your valuable support for our students,
Yeah.
particularly the final year students. We are also means looking on that GS. Why?
Okay.
Because already the GS course is there in their academics and the laboratory is also there.
Okay. Okay.
And now we want to keep ready them for that industry, sir. Mainly,
Okay. Yeah.
some of the students are really they are doing a very good in their projects, mini projects are these
Yeah. Good.
internships also on GS, so that
Good.
further we'll take it to next. Okay, thank you, sir. Thank you, means Om Shira, sir.
Okay.
And
Pleasure.
we'll continue further lectures, sir. Thank you,
Sure.
sir. Thank you.
Sure. Sure. Pleasure. Pleasure. My pleasure. Okay. Thank
Okay,
you
sir.
all. Thank you all.
Thank you, ma'am, for supporting this event. And Lakshmi madam, thank you, ma'am, for conducting this
Thank you too.
um, event for
Thank
our.
you, faculty who are there in the meeting.